Let's look at what A-level further maths is like. This question was worth 7 marks. Like with any proof question, let's just see if it works. When we substitute in 1, which I'm going to call our base case, we get a 16, so it works. But I want to prove this for every single value of n. So next up, I'm going to assume f of n is true when n is some particular value of k. Now I don't care what that value of k is, it just needs to be a value. So if I'm assuming the function is true for k, therefore the function of k, which is this statement here, I've just swapped the n's with the k's, must be equal to a multiple of 4. So let's just call that 4h, where h has to be an integer. So why is this going to help me? I'm now going to consider k plus 1. So what that means is I'm going to look and try and see if I can prove that the value after k is also correct. So my function of k plus 1 is going to be the n's replaced with k plus 1. I need to show that this can be written as a multiple of 4. So I want this function to end up as 4 multiplied by something. Well, what do we notice about these first 3 terms now I've done a bit of expansion? Well, these first 3 terms are actually equal to my function of k. And recall, that was equal to 4h. So this is the maths in one go. What we've then done is substituted in our f of k function and factorised out 4. What we now need to do is bring this all together and write a conclusion. So our statement's going to read, if f of k is true, therefore f of k plus 1 is true. And now remember my first line, the base case was that f of 1 is true. I proved that. So therefore, every single value of k greater than or equal to 1 must be true by induction. I hope you enjoyed. If there's any other further maths questions you want me to go through, please put them down in the comments.